So the remaining part of this practical number 5 is nothing but the differentiator. So here also we have to design a practical differentiator. Now in ideal differentiator, we know that in ideal differentiator we required only one capacitor, that is C1, and a feedback resistance RF. But here also there are some problem related to the bandwidth as well as noise at the output end. So in practical differentiator, we are connecting extra component, that is CF, in parallel with the RF, and R1 in series with the C1, that is nothing but the input. That is connected to the input side at the inverting terminal. So this is what the complete circuit diagram of the differentiator. So according to the circuit, we are just place component and form a circuit on a breadboard. Here also this resistor, so this is nothing but the resistor R1 and this is capacitor C1, which is connected to the inverting terminal, that is in series, and this capacitor C and this resistor R, it is in parallel and it is connected to the pin number 6 and pin number 2, it is in feedback, and one resistor, that is compensating resistor, connected in between pin number 3 and ground, and we are just taking the output at pin number 6 through this yellow wire, and we are providing supply, that is positive supply, positive VCC from to the pin number 7. We are connecting minus VCC at pin number 4, and we are providing an input through this green wire from this function generator, as here we are providing a square wave with 1 kHz frequency as an input with 2.9 volt as an input voltage. So this is nothing but the input which is provided through the function generator to the pin number 2 of the differentiator, and simultaneously we have to observe the output from this pin number 6. This is nothing but the pin number 6 which is connected to the yellow wire, and it goes on a CRO. So if you observe here, we are getting a square wave as an input, because simultaneously when we are providing a input to the pin number 2, simultaneously a second connection is made, and that is connected to the CRO for observing the input. So this is nothing but a square wave as an input. Now we know that for differentiator we are getting a spike as an output. So if you observe here, we are getting a spike, that is when it goes down we are getting a positive spike, and when it is negative to positive or 0 to 1 level, it crosses 0 to 1 level, we are getting a negative spike. So differentiator will just differentiate the input square wave, because we know that for differentiator for constant value we are getting a 0 output. So as we are providing input to the inverting terminal, so inverted output we will get the inverted output. For positive we are getting a negative spike, and for negative we are getting a positive spike. So when it goes up, that is positive spike, we are getting a negative spike, and for negative, when it crosses the 1 to 0 or it transit from 1 to 0 level, we are getting a positive spikes. So this is all about the experiment number 5, that is remaining part of the experiment number 5, that is differentiator circuit. So here we have to just write down that when we are providing a square wave as an input, we are getting an spike at the. So thank you very much.